Hi everyone. So today now we'll be starting with the topic motion and rest. Alright, it's an important topic. Try to focus, understand each of the things I'm about to say, motion and about rest. Alright, it is an important topic that you will need to remember throughout your life. Alright, but it is a relatively easier topic. So let's start. Okay, basic terms related to motion. Now, what is motion? Okay, if we go back, let's say what is motion. Motion is something moving. Okay, moving in a direction. Okay, what is something at rest? Not moving. In simple terms, not moving. I'm sitting somewhere, I'm at rest right now. If I was walking, I would be at motion. All right, so it's the basic definition. Now we go into more broader terms. What is motion? Basic terms related to motion. Okay, we can't just say walking or moving. We should also say motion refers to the change in the position of an object with respect to its surroundings. Okay, you know I'm walking. Okay, if you see me walking, you know I'm walking. But how can you say that I'm walking? All right, are my legs moving? Is that what motion is? No, motion is changing positions. Okay, changing positions with respect to the surroundings. Now, what is surrounding? Maybe the ground. The ground is not moving, but I am moving. Okay, that is motion. What is rest? Not moving, not changing position with respect to time, with respect to the stationary objects in the surroundings, with respect to the ground. I am not changing, I am at rest right now. Okay, displacement. What is displacement? Supposedly I go from A to B. Okay, maybe the distance was not that similar. Okay, supposedly A is here, this, here is B. Okay, here is B. Okay, now from here to this point where B is, this is displacement. Okay, this is displacement. Okay, the person who is driving a cycle over here, over A, okay, and has gone to B. Okay, this would be the distance, but the change in position, okay, the relative change in position, not covering the distance, just the change in position. How far is this? It is displacement. Okay, displacement is the shortest distance between the initial and the final positions. Like I said, A and B. What is the shortest distance? This line, not traveling all the way, just this line. Okay, speed. What is speed? Speed is changing distance with respect to time, but changing a larger amount of distance with time. Okay, speed is the distance covered by an object in a given time. Okay, what we call speed is S is equal to D upon T. Okay, D upon T. What is D? It's distance. What is T? It is time. A person cycling, or you can see a picture over here of a motorcycle. Okay, it is covering supposedly this much distance in only 1 second. Okay, in 0.5 seconds. Okay, that is how we define speed. Okay, covering more distance in less time. Okay, what is the speed of your writing? I am writing more in less. Okay, that increases speed. If I was writing less in less time, that is my speed will be less. Okay, if D is increasing, okay, if you go over here, speed is equal to distance upon time. If D will increase, if the numerator increases, okay, this value will increase. Okay, but if T increases, okay, this whole value, as denominator increases, the whole fraction will decrease. So S will also decrease. If I am covering larger distances in a unit time, that means my speed will be more. If I am covering shorter distance, a given distance in large amounts of time, then my speed is less. Okay, acceleration. Acceleration is the rate at which an object's velocity changes over time. Okay, what do I mean by velocity? Velocity is something like changing directions. Velocity is speed with directions. Going in this direction, going in this direction, going in this direction with some speed. That is velocity. Velocity is the speed of an object in a given direction. Acceleration. Acceleration is the rate at which object's velocity changes over time. Okay, Acceleration, you've seen your cars, your bikes, you give race to it, okay, it will accelerate. Okay, accelerate means covering some distance, covering some speed in time. Okay, so the basic formula of acceleration is speed upon time. Okay, so here in speed the SI unit was meter per second. In acceleration is meter per second squared, m upon s into s. How did we get this? T divided by d, that is speed, again divided by t. Okay, so this will be t squared. T into t, sorry, t into t is equal to t square. Okay, so that is meter per second square. Distance, as we all know, is the total path length covered by an object. Its unit is in meters. If I go over here and this part, and then I covered this part, then I covered this part, then I go this part, all this added will be the distance. Okay, suppose this was 1 meter, this was 2 meter, this was 1 again, this will amount to 4 meters. I traveled 4 meters, but the displacement would be less. Supposedly this is only 2 meters. Okay, displacement is lesser as compared to the distance. Okay, that is with respect to the position. Okay, now we come to speeds formulas. Okay, so write d upon t, okay, meter per second, always remember this. Velocity, displacement upon time. Why displacement? Because displacement has direction. Okay, it is a vector quantity. Vector means direction and magnitude. If it was scalar, it won't have any direction. So displacement upon time. Don't put velocity as distance upon time. Distance upon time is speed. Velocity is displacement with a direction. Okay, here we have put it as delta x upon t. Okay, now it is also meter per second though. Meter per second. Okay, we write it as m by s, small m by small s. Acceleration, like I said, m upon s squared. Okay, meter per second square. This is how you pronounce this. Okay, change in velocity upon time. Okay, change in velocity upon acceleration is also a vector. It also has direction. How do we measure speed and distance? We use these devices: speedometer, odometer. In your car handles, you've seen this, you know, this clock-like structure behind the steering wheel. Okay, you can see it over here. Okay, see it over here. This determines the speed. This shows 60 km per hour, 40 km per hour. What does that mean? You at this given speed, I would travel 40 km in a given hour. I would travel 60 km in a given hour. Okay, since the distance is increasing, remember what I told you, as d increases, speed will increase. Okay, this shows increasing speed. Okay, a speedometer measures this. Okay, a speedometer measures this. What is an odometer? Odometer measures the distance. How much have I traveled? How much my car, okay, how much has my car traveled in this direction with supposedly 40 km per hour I was using, okay, my speed. How much will I cover in the hour? 40 kilometers. So my odometer will read 40 kilometer. Here is an example of an odometer. Okay, it shows how much your car has traveled yet. Okay, go in your cars and see. Motion and rest. What are the types of motion? Okay, there are various types of motion. Obviously, I'm not always walking or running. There are other motions that are happening around us every day. Okay, so types of motion: rectilinear motion, circular motion, periodic motion, and oscillatory motion. Rectilinear moves in a straight line. Always remember, linear means in a straight line. Throughout your higher classes, linear means in a straight line. Collinear, arranged. Straight line. Okay, Circular motion, going in circles. What is a circular motion? For example, the wheel of your cycle, wheel of your car, it's going in a circular motion. Okay. Periodic motion, something that repeats itself, repeats itself. Here the example of a periodic motion would be rotation of the earth. Rotation, we always have day and night. Okay. After 24 hours there will be day. Earth is moving, earth is rotating in this way. Okay, it will come up to this point after 24 hours. Okay, it will go over here, again reach 24 hours, again reach 24 hours. This is periodic motion. Oscillatory motion, oscillation is movement about something. All right, supposedly this is a point that I take to be my point of oscillation. Okay, and there is a pendulum. Okay, it will go this way and it will come back this way. There's a to and fro movement. This is called a to and fro movement about this line. Okay, pendulum swinging. This is oscillation, back and forth about a fixed point. Okay, you can also say periodic and oscillation. This movement is also periodic. Okay, I can say that this pendulum goes over here and comes back in 2 seconds. This is periodic. Now I will come to uniform and non-uniform motion. Alright, this is an important topic. Uniform motion, okay, covering when an object covers equal distances in equal intervals of time. It is said to be in uniform motion. Okay, equal distances in equal time, it is remaining constant. Okay, here I will cover 10 meters over here, 10 meters over here, 10 meters over here every 5 minutes, 5 minute, 5 minute. I again cover 10 meters. This is all uniform motion. Okay, now coming to non-uniform motion. Supposedly I am lazy, I will go 5 meters in 1 minute. Then I realize that I should cover up. I went 10 meters in 5 minutes. Then I went straight 15 meters in 10 minutes maybe. Okay, so this is not uniform, this is not constant. All right, these are two motions. Okay, these are two types of motions that happens around every day. All right, for some things maybe uniform motion is required, for some things maybe non-uniform motion is required. Both happen, you should know both. All right, thank you.